This lesson is pyramids and cones, surface area and volume. So first of all, the definition. Pyramid. A pyramid is a polyhedron, that means a 3D shape made up of polygons, in which the base is a polygon and the lateral faces are triangles. The lateral faces are triangles. So a prism looks different than a pyramid because a pyramid comes to a point. So instead of having two bases that are congruent in parallel, like we had in a prism, we only have one base, and then all of the lateral faces around the sides will come up to a single point up at the top. And that means that the lateral faces then will be triangles rather than rectangles. We're used to seeing pyramids with a square base, but the base does not have to be a square. Okay, so a few more definitions. The intersection of two lateral faces is what's called a lateral edge. So on this picture, the lateral edge would be one of these segments here, where two of the triangles are intersecting each other. That's a lateral edge. And then the intersection of the base and a lateral face is called a base edge. So the segments like, for example, that one and that one, okay, those are base edges. I should have just said lateral up there. Okay, this is a base edge. The perpendicular distance between the base and the vertex of the pyramid. The vertex is that point where all of the triangles come together at the top across from the base. That's called the vertex. And if you were to drop a perpendicular from the vertex, so if I were to drop down a perpendicular to the base, that would be the height. Okay, also known as the altitude. The perpendicular distance between the base and the vertex of the pyramid is the altitude or height of the pyramid. Okay, all of the pyramids that we're going to be using in this lesson are going to be regular. That means that the pyramid has a base that is a regular polygon. The base will be a regular polygon. Remember, that means equal angular and equilateral. And the height meets the base at the center. So a regular polygon is a pyramid whose base is a regular polygon. And when you drop down the altitude here, that'll be the center of the polygon. So basically the vertex is directly above the center of the base of the polygon that's the base. Okay, on this picture, you see what's called a slant height. So the slant height is different than the normal height or altitude because the slant height is actually the height of one of the triangular faces. So if you were to look at this triangle right here, the slant height is the height of that triangle, the altitude of that triangle. Okay, so the slant height of a regular pyramid is the altitude of any triangular face. And we use the letter L. It's like a cursive looking lowercase cursive L for slant height. I don't really know why, but that's just what we use. Okay, so again, the height and the slant height are different. The height is what you see in purple. Okay, what you see in purple there is the height. That's how tall the pyramid is. The slant height we're going to be using because it gives you the altitude or height of each of the triangles on the lateral faces. So we have formulas that we'll be using here, and the variables that you'll see in your formulas will be capital B is the base area, capital P is the perimeter of the base, H is the height of the pyramid, and then what's new is the cursive lowercase l means slant height of the pyramid. So our formulas here for lateral area. Lateral area is just the lateral area for a pyramid. It's just the sum of the areas of its triangular lateral faces. And so when you're thinking about the area of one of those triangles, it would be 1/2 base height. So 1/2 the base of the triangle would be that base edge length. The height of the triangle would be that slant height. But because the base is a regular polygon, all of the triangles all the way around will be congruent. Okay, so since all of the triangles are congruent, instead of doing each one of those triangles separately, we're going to do the perimeter of the base and use that to get all of the triangle areas at one time. Again, our slant height is the altitude of the triangular face. Okay, so 1/2 the perimeter of the base, because we're doing all the triangles at the same time. 1/2 because they're triangles this time. So the perimeter of the base times the height of each triangle is the slant height. So the formula would be 1/2 perimeter of the base times the slant height. 1/2 PL is the lateral area for a pyramid. Lateral area is 1/2 perimeter of the base times the slant height. Okay, for total surface area of the pyramid. So that is literally just the area of the faces. So that means we're going to do the lateral area and then add on, which we knew there, add on one base. Okay, the lateral area we just figured out, one base. So we're kind of used to doing prisms now, so we have to kind of make sure that we switch gears here and do pyramids rather than prisms. So just one base. So the surface area is the lateral area, which is 1/2 perimeter times slant height, plus capital B, which represents the area of the whatever the base is. So it could be a triangle, it could be a square, it could be a regular hexagon or any kind of shape, but these are regular pyramids, so that means that the bases will be regular polygons. Okay, for volume, for volume, the volume of a pyramid is the number of 1 by 1 by 1 cubic units that fill the interior of the shape, just like always. And the volume of a pyramid is 1/3 the volume of a prism with the same base area and same height. So the way you find the area of a pyramid, the volume of a pyramid, is you find the area of one of its bases, multiplied by its height, the height of the pyramid, not the slate height, but the actual height. Okay, and then take 1/3 of it. So volume is 1/3. The area of the base is capital B. The height of the pyramid is lowercase h. And that is the formula for volume of a pyramid. All right, so an example here. If Find the lateral area and the surface area of the regular square pyramid. So we know this is a regular pyramid, and we know that the base is a square. So the slant height. Remember, the slant height is what you're finding when you write lowercase cursive l. The slant height is the height of one of the triangular faces. Okay, that's our L. So L is 30 millimeters. Perimeter of the base. Well, it's a square, 20 on each side, 4 sides. So 80 millimeters. Area of the base. Again, it's a square. So side squared, 20 times 20, or length times width, if you want to think of it that way. 400, and this is an area, so that'll be millimeters squared. Okay, lateral area. Lateral area, LA, is just the sum of all the triangular faces, their areas, and it's 1/2 perimeter of the base times the slant height. So that's 1/2. The perimeter that we found back here was 80. The slant height was given on the picture to be 30. Okay, that's half of 2400. So 1200 millimeters squared. And then surface area. Surface area is the lateral area plus one base. Only one base because it's a pyramid. Okay, so 1200 plus, now we have to go find the base area. The base area was 400. So that's 1600 millimeters squared. Next example. Find the lateral area and the surface area of the regular hexagonal pyramid. The regular hexagonal pyramid. Okay, so what they've given us in the picture is we know that a side of the hexagon, and it's regular, and it's a hexagon. Okay, the base is a regular hexagon. Okay, the slant height, that was given on the picture. It's the height of one of the triangular faces, 18 inches. Perimeter of the base. Well, it's regular, it's a hexagon, 8 on each side, 6 sides, 48 inches. Area of the base. Okay, so we're going to figure out the information that we need in order to be able to do the area of the base. That little segment right there is the height of this little segment, is the height of one of the triangles in the regular hexagon. So we're going to think about this triangle right here. Where there are a lot of different ways to do this area. So we can drop the altitude there and figure out the measurements in the triangle here. So it's a regular triangle. That's a hexagon. So 360 divided by 6 would be 60 degrees. That's this angle measure. Cut that in half, 30 degrees. So we know that when we drop in this altitude here, that's going to create a 30-degree 60-degree, 90-degree triangle. All right, so if the side length is 8, that means that the little half the side there is 4, and that makes this 4 root 3. So the area of one of those triangles area of one of those triangles is 1/2. The base of the triangle is 8. The height of the triangle is 4 root 3. Okay, that's 16 root 3. There are 6 of those triangles, so multiply by 6, 96 root 3 inches squared for the whole entire base of the pyramid. 96 root 3 inches squared. Formula for lateral area. 1/2 perimeter times the slant height. The perimeter was 48. The slant height was given to be 18. So that'll be 432 inches squared. Total surface area. Total surface area is the lateral area plus one base. So 432 plus one base area was 96 root 3. And that can't be combined together. So that's just your final answer. 432 plus 96 root 3 inches squared. This is the end of the first part of the lesson on volume and surface area of pyramids.